Hi, for this video we're solving another absolute value inequality, and with this what you want to do is you want to make sure anytime that you have an absolute value equation or inequality, before you start changing signs and solving the opposite equations, you want to make sure that you get the absolute value by itself. So our first step in doing that would be to add 9 to both sides. So once we do that, we have 5, and make sure that you can tell where your absolute value is, that you don't all of a sudden change it to a 1. And we can say that 5 times the absolute value of x minus 8 has to be greater than or equal to 40, since 31 plus 9 is 40. We would then divide both sides by 5 because the absolute value is still not by itself. Don't make the mistake of distributing it in. That will influence your answer incorrectly. So make sure that you do go ahead and divide these. So once you get x minus 8, or your absolute value term by itself, you're going to ask yourself whether you should use or an and inequality. If you remember, if it's less than or less than or equal to, you always use and. So I always read this as less than. If you have great or greater than or equal to, you always use an or inequality. So because we have this rule, we would use an or in between. So remember, with or inequalities, you would just set it up that the absolute value has to be greater than or equal to 8. Or don't forget that anytime you change this sign, it includes the inequality. X minus 8 has to be less than or equal to negative 8. Because if it's less than or equal to negative 8, once you take the absolute value of it, it will give you a value that is greater than 8. So once you get to this point, you simply just have to solve the resulting equations. These ones are both very simple because all we have to do is add 8 to both sides. So we can see that x can either be greater than or equal to 16, or if we add the 8 to both sides, x can be less than or equal to 0. So with this, if we set it up on a number line, we would say that 0 would be here. And so all values that are less than or equal to 0 would give us solutions that, when I plug them in, would yield a value that is greater than or equal to 31. And all values that are greater than or equal to 16 would also give us the same thing. If we plug it back into here, let's say that we picked 17 as our answer. 17 minus 8 would give us 9. 9 times 5 is 45, and 45 minus 9 would give us 36, which is greater than or equal to 31. So we can see that a value that we pick over here does work. If we plugged in 16, that would actually give us, because that would give us 8, and the absolute value of 8 is 8. 5 times 8 is 40, minus 9 gives us 31. So we can see that 16 and above does work for this. If we picked a value, say negative 1 times minus 8 gives us negative 9. Remember, absolute value means that it's the distance from 0, so I would just do 9 times 5 again, which would also give us a value that works. If we picked anything in between, we would end up with a value that is less than 31, so it would not work. So if, like I said before in many other videos, if you've watched them, if you haven't, this is an acceptable way of writing the answer. If you are in a course that requires set notation, you would just write it as x such that, and then you would start with the smaller one, x is less than or equal to 0, or x is greater than or equal to 16. And if you're using interval notation, remember we always start from left to right, so we would start with our lowest value to the left, which is negative infinity, because there really is no lower limit. Our stopping point would be 0, and since it includes it, we would use a hard bracket. Or we start again at 16, all the way to positive infinity would give us values that work in this original inequality. As always, thanks for watching. If you have any questions, or if there's topics that you don't see that you would like additional help with, please just let me know.